My name is Dr. Joanna Berry, and I'm a director at Durham Energy Institute. Today, I am delighted to introduce our new Honorary Professor, Ian Ritchey. Ian was formerly Group Chief Engineer at Rolls-Royce and has a distinguished track record in the aerospace, defence, marine and energy sectors. The professorship at the university is in recognition of Ian's outstanding professional contribution and expert leadership, and his commitment to supporting university research and education. Ian, welcome to the university. What attracted you to build links with Durham University?
Well, thank you, Joanna. I'm delighted to be here. I guess throughout my career, I've always enjoyed working with universities, both with staff and with students. And I've known various people at Durham over probably 20, 30 years. And always been impressed by the calibre of both the staff and the students at Durham. So when I retired from doing sort of full-time executive jobs, I also returned to my native northeast. I was keen to continue building links with universities. Durham being in the northeast and being somewhere I had a high opinion of was really just a natural choice for me.
So Ian, you've been working with Professor Simon Hogg on the Energi Coast Innovation Group initiative, helping to develop the regional offshore wind offer. Would you like to tell us a little bit more about that?
Yeah, sure. So Energi Coast is the regional offshore wind cluster, and there's three strands to what it does. One is about supply chain, one is about skills, and then the one that I'm specifically involved with Simon is around innovation. So that's really about trying to generate innovative new projects within the cluster. But I guess the key thing for me there is what I've sort of realised through working with the group is we do have a very strong cluster in the offshore wind sector in the region already. It's perhaps not as visible as it could be, and I think some of that is partly due to the lack of really having any big OEMs in the region. But what I'm keen to do through the cluster is both raise the game and raise the visibility of that group, and really let us move to the fore of the industry.
And what are you looking for in your time with us? What do you hope to achieve? What are you hoping to develop while you're with Durham University and while you're working with the experts and the researchers and the students at Durham Energy Institute?
Okay, so be honest, there's a selfish element to it. A lot of what I want to do is keep myself technically interested and technically active, and I've always found again that working with the research and education community is a great way to keep yourself mentally engaged. So a lot of it is about keeping myself engaged. I guess what I hope I can do through that is also help people, either help people with their projects, or help them, maybe some students decide where they might want to go in terms of career choices. Yeah, I think more broadly, I have had quite a lot of experience working at that interface between academia and industry. So hopefully bringing some of that experience to bear might be helpful to both the university and to some of the industrial partners that the university works with.
Absolutely. It's never been more important for our students to have access to people who really understand that university industry interface, to be honest. So I guess what advice would you give to a young person interested in a career in engineering?
First thing I would say is go for it. You really will love it. I mean, certainly that's been my my experience. I think engineering has given me a great career. I've had some fantastic experiences, met some great people, and worked on some really interesting projects. But genuinely, I think the other thing I'd say is don't overthink it. I quite often talk to young people who are saying, oh, I think I want to work in aerospace, so do I need to do a degree in aeronautical engineering? Should I work with this company? Should I work with that company? I think the reality is there's lots of different routes into engineering. There's lots of different branches of engineering. Where you start off is not an irrevocable decision. So I would say just pick something interesting. You'll develop transferable skills along the way. you can move between sectors, between businesses. You can move backwards and forwards between academia and industry. So just pick something fun and interesting and go for it, and don't overanalyze. Yeah,
absolutely. So find something that interests you first of all, and take it from there, which is normally pretty good advice. There are some pretty huge challenges facing our graduates, obviously, in not just finding a job, but there are some huge energy-related engineering challenges out there that currently need to be addressed. I've been putting together the new Masters of Energy Systems Management to try and generate a few generations of graduates that are capable of dealing with some of those. What do you feel are the greatest energy-related engineering challenges that need to be addressed at the moment?
Yeah, I think it is very hard to single out there, because the nature of the climate change challenge is we really do have to address across the board on a number of fronts. But I suppose that in terms of what you'd single out in terms of the biggest challenge for engineering is perhaps those ones that are going to be hardest to solve. Partly coming from my own background, I think aviation is going to be one. I think if we take as an assumption that people are going to still want to travel internationally and fly, then finding a carbon neutral way of flying, particularly long haul, is going to be particularly challenging from a technical perspective. I think we can do short haul and medium haul, but long haul is going to be very difficult without a carbon-based fuel. And then the other one, which to a lot of engineers maybe comes across as being more mundane, but I think is actually heating, or basically our building infrastructure generally. It's not an area I'm deeply specialist in, but I just think the scale of the challenge, the amount of housing stock and building stock we need to improve, and we need to give carbon neutral heating and cooling solutions to, is just massive. There's a lot of policy and there's a lot of social change has to come into that, but there is going to be a huge need for affordable technical solutions that can be rolled out at scale. So there's a massive role for engineers in that as well.
Absolutely. And the problems are not, as you quite rightly say, simple problems. They're wicked problems. They don't just need one solution. There are multiple solutions, all of which impact on each other in those two areas in particular. I'd like to move on to something slightly different, although something that's particularly close to my heart. I've mentioned already the Master of Energy Systems Management program that I've put together with engineering and the business school where I currently sit, which I'm very proud of, and launches this September. And within that, there are 8 scholarships which are devoted to being given to people with particular needs. They're given out for people with equality, diversity and inclusivity in mind. I'm very conscious that this particular world is one that needs a little bit of help to improve the gender balance. And I'm interested in your perspective on what maybe might need to be done to improve the gender balance in engineering. I'm going back to the days at my school where, when the careers advisor came round, engineering was always sold to the boys, and very much not to the girls, because it was something that required a hard hat and meant that you got dirty fingers. And I'm conscious that it's not like that anymore. But what's your perspective on improving the gender balance in engineering now?
Yeah, well, I think you've sort of hit the nail on your head in the way you framed the question, but equally I want to be a little bit cautious about latching onto that. I do quite a lot with the Royal Academy of Engineering through their Diversity and Inclusion Leadership Group, which is basically a group of employers trying to move forward on diversity and inclusion within engineering. And sometimes we've been accused of being a little too quick to say the problem is all in the schools. And we have to be upfront and say employers have got a huge amount to do to help universities, professional institutions. Everybody's got a significant role to play. But it's nevertheless true, particularly on gender balance, probably more so than on other aspects of D&I, the challenge does begin in schools, in that an awful lot of young girls get turned off engineering, at age 11, 12, 13. And so the key thing is, exactly as you highlighted, that we need to change the perceptions of engineering amongst school children, but also amongst parents, amongst teachers and other influencers, because some of the attitudes that you mentioned do come from people who influence kids. And to my mind, the most effective way of doing that is having really good diverse role models who can go into schools and show people that, you know, people like us can do it. Yeah, it's not always very helpful for me to go into a school and show that late middle-aged white men can do engineering, because we kind of knew that. It does sometimes then put an awful burden on young female engineers, because they're forever being asked to go into schools and give talks. But I do think that is the single most important thing we can do, is show those role models, show that they aren't always people in hard hats and overalls, they are having really interesting and successful careers, and I think that does work. We just need to create more bandwidth to be able to do more of it.
Sure. We've had a couple of years of very successful International Women in Engineering Day panels of very influential, powerful women in engineering, talking to Key Stage 4, Key Stage 5 girls in local schools. And you're absolutely right, they have left talking about things in a very different way, and feeling and looking very much more inspired than they were going into those panel discussions, the schoolgirls. So yeah, I'd absolutely agree with you on that. What else do you think we as universities could do, and what more do you think industry could do to promote engineering as an exciting career option right across the board? And I'm not just talking about the DEI or the EDI agenda now. I'm thinking more about engineering as a broad option for anybody leaving university or leaving school and looking at their career options.
Yeah, I do think, again, it sort of builds on the previous question. An awful lot of it still is about changing public perceptions. And one thing I would highlight is the Royal Academy of Engineering's This Is Engineering project, which is basically a series of very short videos that went out on YouTube and other social media, that basically highlighted relatively young people from all sorts of different backgrounds talking about the sort of engineering they did. And it was just such a diverse range of engineering, from, you know, kind of things you might expect in civil engineering and in aerospace, you know, right through video games production, creation of perfumes and pharmacy and all sorts of things. And they were just really, really engaging, really, really well produced. And I think gave people something to say, oh, I didn't even realize that was engineering, sort of thing. I mean, I came out of them thinking, gosh, I wish I was, I wish I'd known some of this. Maybe I would have done some different things if I'd realized the breadth of stuff. And again, I think, you know, companies really can contribute to that, just getting out and explaining what their people do, inviting people in to explain what they do, being a bit thoughtful about how they present it. I mean, when I was at school, you'd get some boring guy in a suit would turn up and talk with loads of sort of overheads about what they did, not engaging at all. It's to find a way to talk about it, make it engaging, make it seem exciting. And I think, as I say, I think universities can do that, and industry can do that too.
There's a lot of work being done around the government's levelling up agenda, around trying to ensure that more effort, more time, more money, and more commitment is being made in the Northeast. How do you think that agenda is going to possibly benefit the industrial footprint in the Northeast?
Okay. I guess I often, because of my background, tend to come at things from a big company perspective. But I do think that in order to really make sort of manufacturing and engineering employment stick, it really helps to have a few sort of large scale, what I would call anchor businesses. Certainly you see it in, I spent a lot of time in the southwest of England, you see it in aerospace in the southwest, where you have an Airbus, you have a Rolls-Royce, you have a British Aerospace, and it anchors a huge cluster. I think we've got the bones of that in many areas in the northeast. I think the establishment of a GE wind turbine blade factory in Teesside is going to be a great example of an anchor. I think the British Volt factory up at Blythe will be a great anchor. Nissan has clearly been an anchor for a number of years. What we need, I think, is and I hope that we can secure that through letting up, is one or two more of those anchor businesses that then really the quite strong sort of small and medium-sized business infrastructure we have in the northeast can start to sort of grow and build even more around some of those anchors. But I think the anchors kind of make it sticky. I worry that without the anchors, jobs and opportunity can move away as easily as it can arrive.
And we can only hope that the move of the Treasury up to the northeast and the recent announcement of the move of part of the bank up to Leeds as well, that shift of some government institutions help to be part of that anchoring function as well for business up here.
Absolutely.
That would be fantastic, yes. Wouldn't it? Yeah, absolutely. Which engineering sectors do you think are going to see the greatest growth over the next decade, which therefore might become part of this anchoring activity?
Okay, this is always a tricky one to answer, but I think I'll come back to the climate change conversation we were having earlier. Yeah, the scale of the investment that is going to be needed to meet net zero targets is unprecedented. Much of that investment is going to go into engineered solutions of one sort or another. So the demand for engineers to deliver those solutions, I think, is going to grow significantly. So clearly it's then the energy sector, the power sector in all of its forms. But also end use areas such as transport, such as buildings and other infrastructure, which I know when you actually add all of that up, that's pretty much all of engineering. But I think that is the case. So it's the whole gamut of the engineering skill set, but it's particularly applied to those sectors that are either about the generation of energy, the transport and storage of energy, or the efficient end use of energy, because that's where the challenges have to be met.
And if all of those sectors are going to be growing at pace and at speed, then are we educating enough next generation engineers in the right disciplines to fulfill the skills demand that they're all going to create?
Yeah, I've always found this a very hard question to answer, because if I look at reports from Engineering UK and people like that, for the last 10 years plus, those reports have been telling me that we're on the cliff edge of a massive engineering skills shortage. And yet, frankly, as somebody who's regularly been recruiting engineers throughout that period, I've never seen that skills shortage actually sort of in the flesh. So I'm slightly nervous of crying wolf on a gross numbers shortfall, if you like, and I think there have been times where we've unrealistically raised the expectation in some areas as to how big demand would be, but nevertheless, I think there's something. I think there will be an increasing demand. I just don't think we want to over dramatize it, and I think that will be compounded by the fact that what the EU has given us over certainly the last 10 years, probably the last 20 years, is a steady stream of really high caliber engineering graduates, and actually, interestingly, a much better gender balanced stream of graduates than we've been seeing come out of UK engineering schools. And my best guess is that pipeline is going to get a bit narrower in a post-Brexit world. So I think we probably do need to increase the number of engineering students in response to a steadily but not necessarily dramatically rising demand, but also probably a shortfall in the supply pipeline as well. but then almost sort of back to my comments about people not overthinking their careers. I don't think we want to get too hung up on discipline again. The reality is, whatever we train an engineer in today, in 30, 40 years' time, towards the end of their career, I can guarantee they'll be working on something completely different. And the technology and the skills that they'll have to develop will change so much. Most of the skill set is transferable. I would be much keener to be increasing the number of, almost generalist engineers that we produce, rather than more and more focus in specific disciplines, particularly at undergraduate level. For example, I have always been, for many years, been frustrated by the lack of electrical engineering knowledge and understanding in a typical mechanical engineer. The lack of civil engineering understanding in either the mechanical or the electrical side. So I would be saying, let's not over specialize. Actually, a good broad engineer has got a lot of transferable skills, and it'd be good if they can sort of turn their hands to a mix. They can always sort of specialize later.
Yeah.
Having said all that, I think it is sort of staring us all in the face that all engineers need to be more familiar with all things electrical. The world is going to be more electric in the future. All engineers need to be, or all of us, not just engineers, need to be more familiar with all things digital. And I think to keep reinforcing a systems view and a systems understanding is really important across the board. And I'd rather we focused on giving that to everybody than developing more specialists in each of those three domains.
That's fascinating and interesting. So what, if you take away the technical, what are the most important non-technical skills that you think that graduates in engineering are going to need, that are going to benefit their professional development?
Yeah. So clearly you could draw up a long list, but again, I think in reality, many of the soft skills are things that can be picked up in industry and are perhaps less sort of important to develop in university. But the one overriding thing, and the one thing that I think was a gap when I was educated, is probably less of a gap now, but is teamwork. You spend your entire education really being rewarded on your performance as an individual, and yet the reality is you achieve nothing as an individual as an engineer in industry. It is a team sport. So the ability to work as part of a team, to sometimes lead a team, to sometimes contribute to a team, to be able to work effectively in that environment. And it doesn't mean we all have to be extroverts, and it doesn't mean we all have to be leaders and whatnot, but you have to be able to work in a team. And I think, I think in the time between, since I was at university, I think universities have come on immeasurably in the amount of team working sort of exposure and experience that they give. But more is better, sort of thing. I think that is a single most thing. I think I was 2 or 3 years into my career before the penny dropped, and I realised this wasn't. This was never going to be about how hard I worked. This was always going to be about how well the team worked together.
That's interesting. The new program, as one discrete part of it, we've actually got a team working module, an assessed module on team working, which I'm really looking forward to. And it brings me to another question in this space, which is that I think part of that, it's not a question, it's a comment that I'd be interested in your thoughts on. It's also going to have to be around multicultural team working increasingly, which is maybe part of the post-pandemic world where we're all going to have to work more remotely in remote teams, which is going to be an interesting dynamic, but we're all getting used to that now. And remote team working is an interesting concept in itself, but also it's going to have to be interdisciplinary, cross-cultural remote team working, which is not something that historically has been a big part of this world. And I think that's something that most disciplines are going to have to get used to. Do you agree with me on that? Do you think it's going to be something that people will have to start to get used to?
I'm absolutely sure. I mean, even without the pandemic, the world was becoming more global. We were already doing a little more remote working. I'm a firm believer that yeah, the pandemic has accelerated a number of things, but many of them probably were happening anyway. So yes, I agree with you. I wish I knew a good way of tackling it, because yeah, I have worked in distributed multicultural, multi-geography teams, but the only way I've ever found of making the work is to invest some time up front with the team face to face together in a room. Once the relationships are built, then I think it is relatively manageable to get a team to work that way. But I think when you're in that sort of forming phase of a team, right now, I'm not even sure I'd know where to start with getting that team to sort of gel and bond without some proper sort of face-to-face contact, some proper getting to know each other. But I'm sure people will figure it out.
There isn't much substitute for the face-to-face. I think I agree with you on that. While we're on the pandemic, what other lasting consequences do you think that the pandemic might have on the engineering profession in particular?
Yeah, I think particularly for engineering, as opposed to some of the more general things that we've just been talking about, I think the pandemic has shown us how quickly things can be done when they need to be. The headline that I guess everybody sees is the development and then the deployment of vaccines. But I think something even more strongly engineering driven, people remember the ventilator challenge work that happened early in the pandemic. I mean, that just completely upended views on how long it would take to develop and certify a ventilator. So I really hope that is going to change our mindsets on how long it might take to develop and certify a new aircraft, or how long it might take to develop and certify a new wind turbine, or a new heat pump, or whatever it takes. I think some real sort of realization that actually, yeah, we've talked about concurrent engineering and all of the things you can do to speed things up for years, but actually, I think there's been some really good examples during the pandemic of people actually doing it well, and it working. So hopefully we can, read some of those lessons across.
Yeah, we've had some really interesting disruptive innovation, but also some really interesting disruptive innovation processes that have been fascinating to watch and fascinating to be part of. And I know from my time with the Durham Energy Institute, we've been watching these and been participating in some of them over the past 18 months or so. And a lot of our conversations have been about future energy and what parts of that incredibly complex jigsaw puzzle we should really be focusing on from a research perspective, because I'm lucky at Durham University, we have so many sandpits to play in. What areas of future energy do you think the Energy Institute should be focusing most on at the moment? What do you think is going to be the most important area of future energy for us as a university to be applying the intellectual capital that we have in order to generate intellectual good?
Okay, well, I think two parts to that, really. I think the first part, to be honest, is scale of the challenge is such that almost anything that the university does to move things forward in almost any sector related to energy will probably be good and therefore a worthwhile activity. But for me, I think where I'm concerned that there is probably less sort of intellectual horsepower being applied, and where perhaps there's the biggest benefit to come is to focus at the overall system level. So we have the interconnectivity between generation, storage, transmission or transport of energy, and conversion and end use. That's a pretty complex system, and in a world where you might be generating hydrogen from wind power, storing that hydrogen, using it in the transport system, but equally you might be using electricity directly in the transport system, and you're using electricity and or hydrogen for heating. It is much more tightly interconnected in a world where electricity was only used for a subset of things, natural gas was used for a different subset of things, and liquid fuels were used for another subset of things, and they were much more loosely coupled systems. So I think when you've got that much more interconnected system, then your ability to do things both more cost effectively and more efficiently through optimizing the system, I think will be a lot greater. I think it is a very hard and challenging area, but I think it's also the sort of area where a cross-disciplinary institute can make a big contribution, as opposed to a sort of a single discipline type area, and I think it is going to be a huge part of the solution.
Brilliant. I could sit and talk to you all day, Ian, but I mustn't, and I'm conscious that whilst you are newly Honorary Professor at Durham Energy Institute, and thanks to the Engineering School for bringing you to the university in that position, I need to bring this to a close now, but just to say thank you so much for giving us your viewpoint. We'll be hearing from you, I know, in more detail across the course of the next few years while you are with us. I am going to pull you into the Master of Energy Systems Management as often as I possibly can. I know I will. And I'm sure that you will be delivering seminars, contributing through the advisory board, and helping us through working with students and staff and the Energy Institute. But meanwhile, thank you very much indeed for spending your time, lending us your expertise, and for answering a few of my questions today. Ian Ritchey, thank you very much indeed.
Thank you very much, John. I really enjoyed it.